All right, so here we want to solve log base 6 of x plus log base 6 of x plus 5 equals 2. Right, so we see in this case there's two log expressions on the left side, but on the right side it's not a log, right? It's just a number 2. Right, so that should tell us that we should convert this into the exponential form. Okay, but wait, we notice right on the left side there's actually two log expressions, right? So the first thing we should do here is combine them, right? We should combine them using the rules for logs, right? So what does the rules for logs say? Right, the bases are the same. Okay, most of the time they will be, but there's a plus in between them, right? So if we can combine these two into one log, okay, but by doing so, we're going to multiply the arguments together, right? So x times x plus 5. So notice that we get x squared plus 5x, right? And that's going to equal 2. Now we have the one log expression on the left. We have just the number by itself on the right side. So from here, we can convert this into its exponential form. Well, what is the corresponding exponential form here? Well, we get 6 squared, right? 6 to the second power is equal to x squared plus 5x, right? Now we have a quadratic equation that we should be able to solve, right? So let's simplify everything, right? Let's subtract the 36 over. So we get 0 equals x squared plus 5x minus 36. Now you notice we can factor this one, right? It becomes x plus 9 times x minus 4. So we get two solutions for x here, right? We get x is equal to negative 9 and x is equal to positive 4. Okay, so maybe at this point you feel good about yourself, right? We got two answers here for x, right? But remember, we always have to check our answers though. Right? The reason why is because the domain of a log function is 0 to infinity, right? What does that mean? It means that we cannot end up with a negative value here, okay, for the argument. Okay? But check it out. What happens when we plug in the negative 9 here, right? We get log base 6 of negative 9 plus log base 6 of negative 4 equals 2. Right? And in itself, log base 6 of negative 9, right, this does not exist. I mean, neither does this guy here, right? So what does that mean? It means that, now don't be fooled, right? We did all the correct math, we made no mistakes, and we got x equals negative 9, right, as one of our solutions, right? But when we plugged it back in, it did not work out. So that makes it an extraneous solution. Okay? But once again, don't be fooled, right? It doesn't work. Okay? 4, however, does work, right? When we plug the 4 back in, we don't get a negative result or a negative argument, and it will turn out to be the correct answer here, right? So here, the only answer that we get is 4.